All right, this is my speed control circuit. In it, I have implemented a display. I have a keypad. I don't think that's anything specific to the lab, the project requirements. I'm using switch interrupts, and then in my code, I have a timer. And what this does is, as you can see on the screen, hopefully you can see it, not too blurry, there's a 0. That object on the screen will range from a 0 up to an A, a hex. And that's an indicator of the speed. So if I use this button here, it slows it down. I use this button here, it will increase the speed. So I'm gonna press that button, and then you should see it switch to a 1 and start moving. And if I do it again, it picks up a little bit of speed and changes to a 2, and then goes to a 3, and then to a 4. And it will go all the way up, and then probably really blurry right now. So I'm gonna activate this read switch, and you can hear the buzzer, and you should be hearing it go slower and slower and slower. And that's an easily heard audio demo of the way the speed changes. So I'm gonna kill that. So with the keypad, instead of incrementing one at a time, I can jump from one to the other. So I just hit 0, and that has stopped it. And then I can jump. I'm gonna put this back to put this back on the read switch, and I can go up to max. And then I can jump down to say 5, and then I can go to 7, and I can go to 6, and I can just jump around like that. So in my code, I took all the functions that are not directly related to what's going on and stuck them in my driver header to clean up this code, because it was originally, at one point it was really, really big, like almost 1,000 lines. So what's going on in my code is I have a global variable here that controls the timer period for a system timer. And then I have a variable here that's a timer adjustment. And what goes on here is I have my port 1 handler that it has some limits here, so it can only have the button pressed so many times. But when I press the button, this will increase the timer period variable, and then it will reinitialize the system timer, and then it will continue going. On this side, switch 2, it will decrease the timer period. And the way the system timer works is whatever you set that period to be. So in this, it's initially 10 million. So it'll count to 10 million, and then a system tick will fire, and then it'll start over. So in my code, when the system tick goes off, it jumps into this system tick handler. I have initial cursor coordinates for my display, and so what it'll do is it will check to see which of these blocks it belongs in. These blocks are specific to different parts of the display. So this block here is this top side of the display. This is the left side of the display. This is the bottom side of the display, and that's the right side. So when it goes in there, it'll decide on which block it needs to be in, and then it will set the cursor to whatever the current XY coordinate is. It will decrease either the X or Y, depending on which block it is, or it'll decrease or increase it to move the display over one block. And then depending on what the current timer period is, it will output a different number to the screen. So the amazing thing about the timers is the way they allow us to do things in parallel, to do multiple things at the same time. Because originally the code that I had for the display was a function that would start in the upper right corner, and then it would just rotate down to the side. The problem with it was that it would start the function, and then I couldn't change the speed. I could change the speed, but it wouldn't update until after the function was done. So with this, it will update actively while it is updating the screen. And that is really the beauty of the timers, and allows us to do a lot of things at once. So that is my project.